Hello, everyone, and welcome to the Daily Space for today, December 20th. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a variety of different stories ranging all over our solar system and beyond. But before I do that, I just wanted to remind all of you that the Daily Space is produced by CosmoQuest. Check out cosmoquest.org, which is your place to contribute to science. We are a production of the Planetary Science Institute, working in collaboration with Youngstown State University, and we're sustained by your subscriptions, and every bit really matters. So if you find you miss an episode live, that's okay. All of our episodes get archived over on YouTube, and those of you watching over on YouTube, if you ever want to ask questions, check us out live, most Mondays through Fridays at 1 p.m. Eastern. So for today's first story, we have a tale of planetary seismology. The InSight lander is sitting on Mars, very carefully deploying its instrumentation. This rather odd photo that to me looks more like something that's going to explode than something that's going to measure the shaking of a planet. This very odd looking instrument is the seismograph that InSight is in the process of deploying. It has reached out almost as far as its arm can reach, placed the seismograph on a nice level piece of soil, and placed it slightly crooked. It is currently slanted about 2 to 3 degrees, so they're going to be very carefully working to nudge it ever so very slightly until it's perfectly laid out on the surface. Now, all those cryptic symbols on the top that you see, those are denoting which piece is which, and helping their camera get more accurate understandings of exactly how everything is laid out. So we are waiting now, and as impatient as I am for the data, and as impatient as the science teams are for the data, they're actually ahead of schedule. So it feels like we're waiting forever, but because of the perfect landing, because they landed in a place that was exactly what they wanted, they got this seismograph out on the surface far faster than they thought they would. So instead of waiting till January, we're going to have a December Christmas of seismographic data. Now, moving on, we have more stories of pretty objects. In this case, the object that we have is Comet 46P Verton. Now, this particular comet, which you can see up in the upper left-hand area of the image, recently passed near the Pleiades system. This is also Subaru in Japanese, and this caused pretty much every astrophotographer who thought they could to try and take a pretty picture. And this is a particular one that was taken by Barbara Schaefer down at Louisiana State University. We also had an amazing combination of Comet 46P shining next to the Pleiades the same time the Geminids were going on. You can see the two stars of the Geminids right there. Now, it's not just the amateurs who are out there taking amazing images. We also had the Atacama Large Millimeter Array getting in on the action. This particular telescope tuned in to the molecular light of hydrogen cyanide. While deadly to human beings, this particular gas, well, it shines just the right color of light to be detected by this millimeter array down in Chile. These two images aren't actually shown at the same scale. The one on the left, which is taken in, as I said, the color of light that's given off by hydrogen cyanide, it actually has 1,000 times the resolution of the optical image on the right, allowing us to see deep into the core and get a better understanding of what's just going on, which in this case it's a blob of ice going around the sun. In fact, it's a blob of ice going around every 5.4 years that this particular time around is located 30 times the distance of the moon away from the Earth. Now, comets are such that their core might be a couple of kilometers across, but that cloud of gas and dust that forms around the core, what we call the comet's coma, it can be 50,000 miles across. And the tail of the comet, which in this case is pointed directly away from us, so we don't really get to see the tail this time, it can be 1,000,000 kilometers in length. So one little piece of ice can make a mess of a whole lot of outer space. Now, while this is pretty, this isn't the prettiest picture of the day. The prettiest pictures of the day come to us from the Hubble Space Telescope. Scientists have recently figured out a new way to map out the distribution of dark matter in galaxy clusters, and this is to use what we call intercluster light. In these two images of the galaxy cluster Abell S1063 on the left and Mac SJ 0416 on the right, we see beautiful galaxy clusters with thousands of galaxies spread into a fairly small volume of space. Now, in these two systems, you see a faint blue glow in both of the systems, and you also see stretched out bands of light. Those bands of light, which we refer to as gravitationally lensed galaxies, those are actually background objects where as their light tries to shine off at an angle, it gets bent by the gravity of the cluster and directed towards us. And it might be a whole bunch of different light that was headed off in all different angles that all gets bent down towards us. So we see these weird background distortions that are indicating there's massive amounts of gravity in this system. And as we expose our telescope images over and over for longer and longer points of time, we start to catch the faint glow of individual stars that have gotten stripped out of all these myriad galaxies and are now orbiting on their own in the intercluster space. It's been figured out that these particular stars end up falling into the distribution of dark matter within this galaxy, or rather within this galaxy cluster. And those individual stars form this faint intercluster light. And that light, while it's not coming from the dark matter, it's coming from the stars. Those stars trace out the locations of the dark matter. So by exposing our telescopes long enough in this particular situation of galaxy clusters with free-roaming stars that are attracted gravitationally to the dark matter, we can actually see where the dark matter is located in this intercluster light. This is much easier to do than the complex gravitational microlensing that we've done in the past. It just takes a whole lot of telescope time. But this gives us yet one more way, in at least one kind of location, to map out dark matter, which we still don't really know what is. And it's looking more and more that it's not the weakly interacting massive particles that we used to think. Now astronomers are even starting to think maybe this is axions, maybe this is some other form of weird matter where the universe proved itself once again to be more creative than we are. So we're going to keep an eye on this science and watch as it develops and enjoy the amazing pictures that happen to come with the scientific discoveries. This is one of those things that makes us really lucky as astronomers. In some sciences, they take amazing scientifically rich pictures and they look like nothing. We get to take images that are simply amazingly beautiful of objects half a universe away and do our science. Now, in order to do our science, unfortunately, we do need funding. And before I go to answering your questions, I just want to remind you one more time or it's not the last. I'll be doing this again tomorrow. But next to the last time, I want to remind you that this weekend we're going to do a 40-hour fundraiser to try and raise funding to keep CosmoQuest going into the new year. We have a fairly large staff that puts together all of our citizen science projects, that puts together educational materials, that produces this stream, that does, well, all the different things that it takes to make it possible for all of you to both learn science and do science over at CosmoQuest.org. Now, since 2012, we've been largely funded by NASA. Not entirely. We've had to do various amounts of fundraising as well. But for the past 3 years, we've been funded entirely by NASA. But starting January 1, that's not going to be true anymore. We'd been warned that cost overruns from the James Webb Space Telescope, as well as policy changes at NASA, might lead to our funding being cut. And it was. And we're now trying to figure out how to keep the lights on and make payroll while I look for new funding from new federal agencies. So I can't do this alone. My part is I'm going to be working my butt off writing those grants, and I'm only going to take salary from the grants I'm able to bring in for the project. But I need your help to pay everyone else on our staff, to pay everyone else on our team. And pretty much everyone's going part-time. Let me rephrase that. Everyone is going part-time. And we need $60,000 to make it long enough that we think we might be able to bring in some extra funding. Can you help? We're going to sing for our supper. We're going to produce 40 hours of content this weekend, and we're hoping that you will help. Every dollar, every bit, anything you can give really will make the difference. I don't want to fire my staff for Christmas. Help. Anyways, okay, I'm now going to do something that I'm trained to do. I'm going to answer your questions. I'm actually wearing a shirt today that says, let me see if I can stand up and show you the shirt on camera. This is my I Hate Fundraising shirt. Damn it, Jim. I'm a scientist, not a fundraiser. So, thank you, Veronica, for the 5 bits. Thank you so much. And my green screen was escaping. So, okay, now to answer your questions. Let me scroll back and see. Yes, Bones still lives. It's very true. And let's light up the chat for those bits. Thank you so much, Scott Bragdon. Thank you so much. So Hanny's Vorverp is asking, does the shape of dark matter clouds make sense for dark matter being one type of particle? It doesn't really tell us that much about the particle itself, other than it doesn't seem to interact except via gravity and is very small and doesn't really have a collisional cross-section. So 2 clouds of dark matter will pretty much just pass through one another. Yeah, that's pretty much all we know. Is it has mass, there's a lot of it, doesn't really interact, doesn't really collide, it's just kind of hanging out there going, I shall gravitationally move everything, and that's what it does. Other questions? Henny also asked, has Earth ever been engulfed in a comet's coma as it passes? Not so much as engulfed, but I want to say it was back during the 1930s. We were pretty much in the tail of a comet, and it caused an amazing meteor shower that led to a song, I want to say The Falling Stars Over Alabama or something like that. I will Google that in a moment. Let me just scroll back and see if there's any other questions. Nope, not in the back. So let me see if I can Google this one star storm, meteor shower song. Stars Fell on Alabama. It's a 1934 jazz standard. Okay, you're not telling me what I wanted to know. My brain is full of some of the most esoteric information. Okay, meteor storm Muse behind Stars Fell on Alabama. An 1833 storm was with unusual active display of Leonids. So astronomers estimate that a meteor storm on November 12th to the 13th bombarded Earth's atmosphere with more than 30,000 meteors an hour, blazing over Alabama as well as most of the rest of the country. So let me go ahead and share this out with you. Comets make the majority of meteor showers, but we do have a few meteor showers, like the Geminids, for instance, that are associated with things that look like asteroids, behave like asteroids, but might actually be dead comets. Comets and meteors are kind of a continuum of objects where you go from mostly rocky to mostly icy, and everything in between exists. And it appears that you can get a comet where it's mostly glazed over with organic compounds and it doesn't have a lot of active melting ice and volatiles doing their volatile tail coma forming thing. But until we can cut one open, we can't really tell what is the ratio of rock to ice. Other questions? Oh, thank you, Susie. Yeah, 30,000 an hour. It was shockingly crazy meteor storm. The image associated with it. Let me see if I can pull up the image to share with you guys. There's some old pictures that were made that just blow my mind. Nope, that was not the correct image. Sorry, this is not the most interesting thing for you to be watching. Just trying to copy the image, and my computer's like, no, you cannot have this image. Come on. Open image in a new tab. Let's try that. Websites are getting better and better at making it difficult to steal images, but I shall defeat them. Plus, this painting's out of copyright, so I feel okay doing that. Okay, so here is the most amazing. This is how they depicted it, where it was so bright that it was casting shadows. Now, I've seen the Leonids do this before. Back in, I want to say it was 98 or 99, there was an amazing meteor shower that looked it didn't look like this, but it cast shadows periodically with the bolids going off. I've seen shadows. I've never seen a full-on storm before, but Earth has. Yeah, isn't that amazing? So do you guys have any other questions? Otherwise, I'm going to get back to the mad preparations for the Hangout-a-thon this weekend. if you guys can do anything to get the word out to your friends, anyone, if anyone in your life has ever complained that science and science education don't get enough funding, this is their chance to put their wallet where their mouth is. So, yeah. Hanny is asking, what dark matter particles are left? Well, we haven't fully explored all of the parameter space for weakly interacting massive particles that are predicted by supersymmetry. They're in the process of doing an upgrade to the collider at CERN, and they'll be able to detect, thank you so much, Grosser, or Grossier, I'm not sure how to say your name, but thank you. Can we light up for the bits? Light up that chat. Thank you so much. Yes, Stormer Joe, they definitely thought it was the end of the world. Thank you, Wonky Sausage, for the follow. That's a fabulous username. So they're going to keep looking with CERN to see if they can find bigger particles than we've been able to explore for so far. They're building new detectors in gold mines to try and catch things as they pass through the earth. We're going to keep looking. We're going to keep trying. The universe, it's just amazing that we can understand any of it. And the fact that there's mysteries, that's fine. We're still, if you watch enough science fiction, you've heard it said we're still a young race. Well, we are. And we'll figure it out in time. So Hanny is asking, would we be able to see that shower today with light pollution and all? Oh yeah, totally. When you have that much stuff blowing up in the atmosphere, you can easily see it. Other science questions? So, I've got nothing else to add other than next week we will be taking Christmas Day off. I'm going to sleep all of the sleep. All of it shall be mine. Other than that, be prepared for 40 straight hours of science. And we are going to have an eco server turned on. So if you want to play games with us, you're welcome to do that as well. So thank you. And wherever you are, I'm losing my voice. This is part of why I'm ending. Wherever you are in the world, have a fabulous morning, evening, or afternoon. And hopefully I'll have my voice for this weekend. Bye-bye.